In this lecture, you're going to learn how to arrange a set of scores into both simple and grouped frequency distributions. Let's start off by looking at the first 18 scores that were placed into the survey results for the course contract in spring of 2012. These represent the heights in inches. All I did was I took the heights that were inputted, say someone was 6 foot 1 inches. I took the 6 feet times 12 and added 1 to get the total number of inches. So this data set here represents the inches of your classmates. If I want to turn it into just a simple frequency distribution, the easiest thing to do is to start off by looking for the smallest value on the chart, in this case 62, and the largest value on the chart, in this case 75, and simply make a table starting at the minimum value and ending at the maximum value. Then go through and simply tally up the values as they occur in the list. So 64, 75, 68, 68, 69, 65, 63, 66, 70, 70. And then let's see, it looks like there's a lot of 62s in this column, so I'm going to count them all. 1, 2, 3, 4 62s total. I'm going to go ahead and mark 4 tallies. Okay, then we have a 66 and another 66 and one more 66, adding to the one I already have, so that'll be 4 66s total, and a 65, and one more 64. If I've done this correctly, then I should be able to count 20 tally marks, no, 18 tally marks I think was the total, because I had 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2 gives me 18. So there's 4, 5, 6, 7, 8, 9 plus another 4, that's 13, 14, 15, 16, 17, and then our really tall person, 18. So this tally here then leads me to be able to do an actual frequency count. These are the same data from the previous screen. So I see I still have 4 62s, a 63s, etc., and 1 75. And I've just taken those tallies and turned them into numbers so that I can see my actual frequency distribution. Now, what we're representing in this first set is a simple frequency distribution because each value had its own tally mark area. What we then do as statisticians is we do something called data reduction techniques, because knowing the individual heights, while it's good information, it may not be necessary detail. So instead, we're going to turn it into a grouped frequency distribution. To do that, I'm going to choose some class intervals. Class intervals are the range in which the data will fall, and to think of them as like being bins, where if you had the height of 62 written on a little slip of paper, it would get placed into a container, a bin, that was going to contain all of the little cards for heights of 62 to 64. This also brings back the idea that we had in the previous chapter of the lower and upper limits. Because what do you do if the value is right on 62 or right on 64? Well, what you've got to do is you've got to think about the range as being having a lower limit and an upper limit. So the lower limit of this range is actually 61.5, and the upper limit is 64.5. So any values following between 61.5 and 64.5 would belong in this bin. So in my frequency table here, that's going to be the first 3 simple bins. So I'll have a total of 7 counts in the 62 to 64 inch bin. For 65 to 67, 6 total. 68 to 70, so it includes 68 and it includes 70, gives me 5. There's none in the 71 to 73 range, and there's our 1 taller person in the last bins range. This particular table right here represents a grouped frequency distribution, and I can turn that into a grouped frequency distribution with tallies as well by simply doing tally marks for 7, 6, 5, 0, and 1 in each of these bins. Let's look at a second example. In this case, the 2011 top 20 Colorado Rockies in terms of the number of games they actually played. So I was able to find the full set of stats just online, and then I sorted it according to the games played. And the first 20 names with the highest number of games played came out in the list. So of course you've got pretty much your starters at the top of this list because they represent the most games played. And then you have some pitchers, most definitely, and some substitute players and some people that went in because of injuries and stuff like that for other people. So the number of games played for these 20 individuals is actually a pretty extensive range. What I'd like to do is I'd like to make a grouped frequency distribution for these data and take a look at how to do that with such a large range of data available. So I've put together a table here in advance, knowing that my maximum is 147 and minimum is 48 because I previously sorted the data. And just to make things nice and easy, I decided that I'd like to have bins that have a range of 10 games played. And so that I can incorporate the entire range, I'm going to go ahead and start with a bin of 41 to 50 games, then 51 to 60, 61 to 70, keep going, 71 to 80, 81 to 90, 91 to 100, 101 to 110, 111 to 120, almost there, 121 to 130, 131 to 140, and finally 141 to 150. Looks like I need a 6 there. Okay, and my 8 didn't get formed. All right, with these bins, I'm just going to quickly place a tally in so that I can count how many games are in each bin. Starting at the bottom, 48 and 48 gives me 2 tallies for the lowest bin. There are no entries for 51 to 60, so I'm just going to leave those tallies empty. 61 to 70, I have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. 73 to 80, 1, 2, 3 of them. 98 falls in this bin, and then 104 in the next, 112, 124, 25, and 27, and 30, 124, 125, 127, and 30, and then 143 and 147 in the topmost bin. Counting those up, I get a frequency distribution of 2, 0, 4, 1, 1, 1, 0, 3, 6, 0, and 2. When we add these up, we should get to 20 because it was for the top 20 Colorado Rockies in 2011. 2 plus 4 is 6, 7, 8, 9, plus 3 is 12, plus 6 is 18, plus 2 is 20. So indeed, we did end up with 20 total scores. And that's how you take a set of data and turn it into both a simple and a grouped frequency distribution.